Hello children, welcome to Yamuna's physics classes. We are here to discuss sign convention of mirrors. That is a part of the section 9.2 ray optics. In the previous video we have discussed major portions regarding the terminology we use in optics and also the sign convention of lenses. Now we have to add few more things here to define that the same thing for mirrors. And before coming to mirrors, let me see what is a mirror and how many kinds of mirrors do we have. So, very familiar mirror is a plain mirror in front of which I dress, I put my hair, everything in front of the plain mirror. And as the word itself, the surface is plain. Meaning, lights are going parallel, the light ray going parallel and getting reflected again coming back in the same manner. Means angle of incidence as well as angle of reflection are the same. Angle I equal to 0, angle R equal to 0 for a plane mirror. So, we are getting the same size. My height will remain the same, width will remain the same, everything are the same when you have a plane mirror. Okay, now what about the other kind of a mirror where it's known as spherical mirrors? So, easy way to learn spherical mirrors is just to get a spoon from your home. If you want, you can pause the video, go to the kitchen, get a spoon like this. And with this spoon, you can clearly understand why you do have that kind of variations in a curved mirrors or spherical mirrors. So this is a spoon, just hold it in this manner. You have two surfaces, one where you take all the things serving, the space you use for the serving space. Whatever it is, you can have it here, rice or whatever you want, you will have it here, the other side. So if you look in front of this, look at this, just imagine this is a mirror and just hold on and watch it. When you look like this, you can see that my size is my face is getting inverted, or I can see my figure as an inverted image in front. And if I make it closer, I see it going to be magnified. So one is inverted, the other thing it gets magnified as you move it for front and back. Just flip it and go to the other side. What you will see? You can see that my image is getting diminished, but it is erect or an upright image. So why this is happening? Is that it means that meaning I and R the angles are different or the law of reflection won't work? Is that the reason? Let us see what's the reason why you have the image variation. We have seen that in plane mirror we are getting the same size of my head, my foot, all in the same level. You don't have the height difference. It's not an inverted one. But when you go to mirrors, whether in this portion or this portion, there is some variation in the images. Why that images are going to be different? And that is the peculiarity of a curved mirror or a spherical mirror. Spherical mirror in the sense, you are taking the mirrors, you are taking this portion, circular portion from the part of a sphere, not this part. This part is taken as a part of a sphere. You can look at this. This is taken as a part of a big sphere. Hence the term spherical mirrors. So you have two kinds of spherical mirrors. One is a concave mirror. The inside portion is like a cave, like this. So it's a cave like this. So we'll say that concave. The other side known as convex mirror. So you will have two kinds of spherical mirrors. One a concave mirror, the other one a convex mirror. So let us go to the detail to see why you have the image variation. You have seen different kinds of images when you are looking front and back. So what's the reason? So let us go to the details. So I told you a mirror is a part of a sphere. If the mirror is a part of a sphere, you can imagine about a ball ice cream. Think about a ball ice cream. We have a ball ice cream with us. And Let's suppose M dash refers to the lid of the ball ice cream. Just the lid. And this is the inner part of the lid where you have ice cream. This is the outside portion. The bluish shaded portion is known as the polished surface. See, this is the mirror. This is the polished area, painted area. Paint, you can see orange shaded paint, and this is the reflecting glazing surface. So this is the glazing surface inside, the polished surface outside. You are placing the mirror in this manner. But when you draw the same figure, you can only visualize the orange line here. You can see only the orange curve here. The same orange curve I have redrawn here. And the central, geometrical central portion of this mirror. This has a geometrical center. If you drop a water drop, you can see that it will be at the center. That point is known as pole of a mirror. A new word, pole of a mirror. So, pole of the mirror is the center portion of the mirror. So, when I draw the figure, I draw this curve and put a center portion as a pole. So, this is my pole. So, this is what I have drawn. Just listen or understand. This is a curved portion I have seen. This is the dot. That is the pole. Okay. Now, look at the rays. This is the principal axis. You can see principal axis is always normal to the surface. Through the pole, it is going, it is normal. So, here this shows angle of I is 0, angle of R is 0. Coming normally, reflecting back normally. Same as a plane mirror. Same as a plane mirror. Only these two lines retrace this path. Just because they are coming normally, they are returning normally. But all other rays are oblique incidence, so oblique reflection. Clear? So the rays are coming from left and they are getting reflected and converging. The word is converging. So it is known as a converging mirror also. Converges to a particular point on the principal axis known as principal focus. The word is principal focus. So what is principal focus? Parallel rays after reflection converges to a point on the principal axis known as principal focus. So that is represented by F. And from the figure you can see that F is exactly midway between C and P, because focal length is just the half of radius of curvature. What is radius of curvature? Radius of this spherical surface, that is CP. So half of CP is equal to FP. Now this is the case of concave mirror. Now what about the convex mirror? So this is the convex mirror where the other side you are using. So the reflecting surface, this is the painted portion, this is the reflecting surface, the silvered portion. So you can see this is the condition. So this portion you are seeing, that is what I have drawn here, M dash, and you can see the center point as P. The pole is drawn at the center. So this is a curved surface with pole at the center. Okay. Now in this case also that ray which is going normal gets reflected normally. Angle I 0, angle R 0, meaning the other rays which are coming parallel to the principal axis. This is strictly going along the principal axis. All other rays are parallel to the principal axis. After reflection, it gets diverged. But we feel like they are coming from a point, originating from a point on the principal axis known as principal focus. So we will say they appear to diverge. They appear to diverge from a point on the principal focus. They appear to diverge from a point on the principal focus. Clear? So 2 points are clear. What is principal focus for a concave mirror? What is principal focus for a convex mirror? Once again, all the rays coming parallel to the principal axis after reflection appear to diverge from a point on principal axis. termed as principal focus. Clear? Now, if the two words F and R is clear, one more thing just to remind, aperture. What is aperture? Whatever be the reflecting surface, it is a circle, for sure it is a circle. This circle has a radius. Whether it is lens or a mirror, it has a particular circumference 2 pi r. The diameter of the 2 pi r is known as aperture. So here, if you are measuring, it will be somewhat 3 centimeters. So light ray is received only in the 3 centimeter diameter portion. So this is the 2 pi r circumference, but the diameter will be 3 centimeters. That is known as aperture. M dash. Okay? With these basic ideas, we will go to sign convention. Sign convention, in the previous video for lenses, I have told all these things, just adding only a single point. Rest of the things we have already discussed, only single point I am going to add. Instead of optic center O, there optic center is the origin. Here, instead of optic center as origin, you will take pole as the origin. That's the only difference. Rest of the rules remains the same. But I will recap once again. So first thing, take the principal axis as the x-axis. This is our principal axis here. This is the principal axis here. Take the same thing as x-axis. So this is x dash axis. That is taken as the principal axis. And origin as the pole. So that's the first rule. Principal axis as the x-axis, origin as the pole. Clear? From origin you have up, y-axis, minus y-axis. Towards up, plus y-axis, towards down, minus y-axis. So that particular point you place the mirror. So mirror is placed, whether it is concave or convex, I place here. This is how you place the concave. This is how you place the convex. Convex in the reverse manner. You have to place the convex mirror here in this manner. If it is concave, you will place in this manner. Light rays are supposed to come from left. So you should make the reflecting surface facing the light. Reflecting surface facing the light. So that's the first rule. Now coming to the second rule. Object has to be at the left. The object should be placed at the left hand side of the mirror or lens, whatever it is. If this is the mirror or this is the lens, place the object at the left hand side so that incident light is coming from left to right. So this is very, very important. The direction of the incident light from left to right. And that direction in which the distance along incident light is positive. So from left to right, that means from the origin, all the measured distances has to be from the pole or the origin. So from origin, as you go to right, it is positive. From origin, as you go to left, it is negative. So distance against incident light is taken as negative. Third rule, from the origin towards up, positive up. From the origin towards negative or down, it is negative. So these are the three things to bear in mind when you come to sign convention. Repeat, always take the origin as the pole, with x-axis the principal axis. Take the incident ray from left to right, meaning object should be at the left. That direction of incident ray is known as positive, the reverse direction is negative. Perpendicular to the x-axis, upward direction is positive, downward direction is negative. That is useful when you do a term known as magnification. We will come to that later. U, V, H, H dash are few more terms we need to learn, that we learn after image formation. So with this basic idea of F and R, let me see what is the values of F and R. How could you give the values positive and negative? So look at that. This is the pole. Image is formed to the left of the pole. This is the pole. Image is formed to the left of the pole, or it is at the focus. So from P to the left against incident light, that is negative. P to F is the distance F. P to C, that's the distance R. As F is measured from P to F, you get it as negative. Again measure R from P to C. So P to C against incident light, that is negative. So R is negative, F is negative because light is coming from left to right. So that's the case for a concave mirror. Then we go to convex mirror. In convex mirror, what is happening? The image is, the focus is towards the right of the pole. Image is formed or appear to diverge from a point which is right of the pole. So directions from left to right, incident light. Images or focus is at a point towards the right of pole. So start from P, measure to the right. In the distance of incident light means positive. For radius of curvature, from P to C. So look at the point F. It is on the opposite side here. Here you can see pole here, focus at the left. Pole here, focus at the right. So center of curvature at the right. So P to C along the incident light, that is positive. So F positive, R positive. But when you learn about image formation, each and every point, when you can keep object at any point on the principal axis. From pole, you are taking F, C, beyond C, and you have placing each and every point. You can place object here, between F and P, at F, between F and C, at C, beyond C, and so on. Accordingly, the image formation also will be at different points. So that is known as image formation for lenses and mirrors. That we will discuss later. At the time, the remaining terms also will be clear. Now we have discussed only F and R and the sign convention. To be keep in mind or to be careful, when you learn ray optics, whatever videos are uploaded, you should see them in the same order from first, second, third, so on. Otherwise, the concepts won't be clear when you go and watch randomly. So for this lesson, sequencing is very important. So whatever videos have loaded first, you just go through that, then you come to the later videos. Then the concepts will be crystal clear. Okay? So thank you for listening. If you have any doubts, please post in the comment box.